All right, we are on lesson 6-5. And again, hope you have your SAB journal out. I hope you have your homework and remembering nearby, and hopefully a sharpened pencil so you can work along with us. If you ever want to practice a problem on your own, you can hit pause before I start to talk about it. Otherwise, let's get right into it. Today's lesson, I think, should be pretty easy for the most part once you get the hang of it, although there's definitely a few that we're going to want to do together so you can make sure you know how to solve them correctly. So what we're simply doing today is addition and subtraction again of fractions. It's just that this time they are greater than 1. So I'm going to sometimes let you keep it as an improper fraction, but for the most part I do want to remind you that it's super important to change those improper fractions into a mixed number. So let's do number 1 as an example of what I mean there. So on number 1, it wants you to add 8/5 and 3/5 together. So the good news is your denominator is going to get to stay the same, and all you have to do is add 8 and 3, which becomes 13/5. But that is an improper fraction, and typically, when you get into like 5th and 6th grade, they don't ever want you to leave an improper fraction by itself. So you might as well just start practicing this now. 13/5, the way that it's written, is simply a division problem. This is simply asking you 13 divided by 5. The way that I like to think about these, though, is kind of asking the reverse question. How many times does 5 go into 13? Well, if I were to count by 5s, that would be 5, 10, and I can't quite make it to 15. So 5 went into 13 2 full times. Well, what was those two groups of 5? That was 10. So that means I have dealt with so far 10 of my fifths here. So then what's 13 minus 10? That's going to be 3. So that actually means that 13/5 is the same as 2 and 3/5. Another way just to see it visually, if you were to draw out your fifths, 5, 1, 2, 3, oh gosh, that was really bad. 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, and you were to show that you had 13 of those fifths. There's 5, there's 10, and then there's 1, 2, 13/5. That's another visual for you to see that you have 1 here, and 3/5 here for 2 and 3/5 total. But now that I have explained that, I am going to go ahead and let you just simply add and subtract for the moment, especially on this first page where we're just doing a little bit of practice. So let's move on with 2 through 6. If you'd like to pause real quick and try them on your own, that would be pretty cool. Otherwise, I'm going to just zoom right ahead. So 6/9 plus 12/9. My denominator is going to stay the same, which is 9ths. And then what's 6 plus 12? That is going to be 18. On number 3, this time it wants me to subtract. So my denominator, again, of 7ths is going to stay the same. 10 minus 3 is 7. Well, that could be easily switched, but I'll leave it. And then on number 4, we are back to addition. My denominator is going to stay the same, and then 10 plus 7 is 17. On number 5, this is a subtraction problem. My denominator stays the same. 9 minus 4 is 5. That's supposed to be a 5. And then on number 6, we've got tenths as my denominator. This is a subtraction problem, and 19 minus 7 is 12. On this next section, it's showing you how to stack these problems, and I want to tell you kind of what I meant before. I mentioned this in another lesson about why they sometimes stack these problems, because you're going to see that sometimes you have to borrow, but also sometimes you can regroup. So this actually makes regrouping really easy. So on number 7, they want you to add 2 and 3/5 plus 1 and 1/5. When I look at these problems, I kind of actually think of them as a 2-digit number. I'm going to just throw out a random 2-digit number off here to the side. So when we solve a 2-digit number plus a 2-digit number, without drawing it, you tend to think of this as your ones place, and you tend to think of this as your tens place, right? So 2 plus 7 means that I have a 9 in the ones place, and then 2 plus 1 means that I have a 3 in the tens place. So we do that same thing here, but we think of this instead as your whole number and your fractional part. So what's 3/5 plus 1/5? That's going to be 4/5. And then what's 2 plus 1? That's going to be 3. But let's look at number 8. Let me give you an example. I'll write it over here so I'm not squishing everything off to the side. Let's say that this time you were going to add together 19 plus 25, right? So when you consider this to be your ones place and your tens place, you'll notice that you're going to have to regroup here, because what's 9 plus 5? That's 14, and we can't write 14 down here, but we can write down the ones place, which was the 4, and we can carry the 1, which was a 10. And now we can finish out this problem. 1 plus 1 plus 2 would be 4. So that would make that 44. So let's talk about what that means with fractions. I've come back over here to number 8. So if I was going to take 2/5 and add it to 4/5, what you're going to notice is that you have 6/5 as your answer. We know that 6/5 is an improper fraction because my numerator is bigger than my denominator. So what actually would be better is if we can go ahead and change this to a mixed number right now. So here's what you need to ask yourself. How many times does 5 go into 6? It goes in 1 time. That means that you used up 5 whole fifths and that you now have 1/5 left over. So 2/5 plus 4/5 is actually 1 1/5. So I'm going to actually delete all of this work. We're going to keep in mind what we just said. And now when I add it, 2/5 plus 4/5, I'm going to write down 1/5 and carry my whole number of a 1. That way I can now add it all together and it's going to be a mixed number rather than an improper fraction. So 1 plus 1 is 2, 2 plus 3 is 5. So 5 1/5 would be the answer there. Now if you kept it the other way, 4 6/5 is actually an acceptable answer there. I just would like you to try out this mixed number one instead. All right, number 9, this is again asking you to add 5/8 plus 3/8. Well, that together actually equals 8/8. What do we know about 8/8? It's actually the same as 1 whole. So my answer here is not going to have any fractional parts, but I'm going to carry that 1 that I just created, and then 1 plus 3 plus 1 is going to be 5. So that's your answer on number 9. And then for number 10, this is going to be another one where, let me get that out of the way, this is going to be another one where I need to have, to carry something. And just as a reminder first, 2/3 and 2/3 actually equals 4/3. I'm going to try to change that into a mixed number. So 3 goes into 4 1 time. That was a full group of thirds I just got rid of. And then 4 minus 3 means that I'm going to have 1/3 left over. So in order to answer this, I'm going to bring my 1/3 down, and I'm going to carry a 1. So 1 plus 5 plus 2 equals 8. So my answer would be 8 1/3. Let's try this now with subtraction. Same kind of deal. It's just this time you may end up having to borrow from next door, which can be a little bit tricky. But this first one's pretty simple. You've got 6/8 on the top. You've got 3/8 on the bottom. So your denominator is going to stay the same. And simply 6 minus 3 equals 3. So then we have 5 minus 3, which equals 2. So your answer is 2 3/8. But let's look at number 12. So this is the same thing that I was just talking about. I'm going to give you first an example of a problem where we have to borrow in order to solve. I can't do 1 minus 9, and because of that, I would need to borrow from my tens place, right? So that means I'm going to change this. Instead of it being a 4, I'm going to change it to a 3. But what that really actually means is rather than this being a 40, I'm going to make it a 30, and I'm going to add 10 to this side. So that means that rather than this just being 1, it's now become an 11. So my problem is still 41. It's just that I now have 30 and then 11, right? So 11 minus 9 would be 2, and then 3 minus 1 would also be 2. So let's see what that means up here when we're talking about fractions. If I am going to take 2/8 and subtract 5/8, I can't do that right now because 2/8 is less than 5/8. So that means I need to borrow from this 6, but I'm only going to borrow 1. So I'm going to change the 6 to a 5, and I need to add 1 whole to this 2/8. Well, I can't just add 1/8. That's not what's happening here. But what I am going to add is a full group of 8/8, because that makes 1 whole in this problem. So what's 2 plus 8/8? That's going to mean that this altogether equals 10/8. And now I can subtract. It's all kind of funky the way that you write it, but it all works in the end. So that now means that I'm going to take 10/8 and I'm going to subtract that and get 10 minus 5 equals 5/8. Okay, then we come back to our whole number. This now became a 5, and 5 minus 4 is 1. So 1 and 5/8 is your answer. If I were you, I would go ahead and pause so you can try 13 and 14 on your own, but I'm going to go ahead and solve them. If you want to just do it with me, totally fine, but I am going to go just a tiny bit faster. 1/5 minus 3/5 I cannot do, so I need to borrow from this 4 to make it become a 3. I'm going to add a full group of fifths here, so 1 plus 5 would make this 6/5. Now I can subtract. 6/5 minus 3/5 is going to give me 3/5. And then 3 minus 1 is 2. And then if we come over here to number 14, once again I'm going to have to borrow. This 5 is going to become a 4, and I'm going to add 6 full sixths to this problem. So 1/6 plus 6/6 is 7/6. That's a mouthful. And now 7/6 minus 4/6 equals 3/6. And then 4 minus 3 is 1. So your answer is 1 and 3/6. I'm running out of a little bit of time, so I'm going to just do one of these problems with you, but I want to explain to you that really this is just showing you the work that we have already done, and it's just going into a little bit slower or explaining it to you with a visual rather than me having to walk through the problem with you. So on this one here, they are showing you simply how they borrowed. So rather than this being 6 2/7 minus 1 5/7, they changed this 6 2/7 by borrowing to make that a 5. Then they added 7/7 to your 2, so that then became 5 9/7. Then they were able to do 9 minus 5 is 4, your 7ths stayed the same, and 5 minus 1 was 4. So don't feel like you have to write an explanation here, but maybe take a look to see how they went ahead and solved those two problems. Number 30, or sorry, that's my page number. I don't know what your page number is. This problem right here is a puzzled penguin problem. I would love for you to try this one out, so if you could go ahead and pause, that would be super awesome. But I'm going to kind of run it through with you now that you've come back, or if you're just watching along with me. So what they did on this problem here, this puzzled penguin basically says they tried to solve the problem, but it looks like they've done it wrong. So they did 7 3/8 minus 1 5/8, and that gave them 6 2/8. But here's what we can see that they did wrong. This 3/8 and this 5/8, they just simply flipped them around. So they did 5/8 minus 3/8 to give them 2/8. And then they left their numbers the same, 7 minus 1 to equal 6. Well, that is definitely wrong. In order to solve this problem, you actually have to borrow from your 7. 5/8. Is that right? Was that a 5 or was that a 6? That was a 5. Okay, good. So this will become a 6, and then I'm going to add 8/8 to this problem to make this 6 and 11/8 minus this 1 5/8. So then 11 minus 5 is 6. Your 8 stays the same, and then 6 minus 1 is 5. So 5 6/8 would be the correct answer there, puzzled penguin. I'm just going to briefly show this to you. They want you to compare them to see which one's bigger. Hopefully you'll be able to figure those out. If you'd like to Zoom call with me one day, I can totally go over some of these answers, but I have run out of time for this one, which is okay. Basically what you're trying to do is to decide which number is bigger. So it says compare each numbers. So that means that 3 2/5 is definitely greater than 1 4/5. And then it wants you to actually stack and solve. So you would go ahead and write this out to solve that problem. Okay? So you will be able to pause on this page, or hopefully it'll end here and you'll be able to see it, but your directions for homework are actually the same as yesterday's. You may either finish any SAB pages we didn't do today, you may zoom ahead to the homework and remembering pages to try to practice some of those, or you can see which IXLs are connected to this lesson and show your work on those. But hopefully you can show your parents your understanding of these particular lessons. And again, if it didn't make sense, log into Zoom and I would be happy to help you out.